How to test a load cell testing and troubleshooting. Are you experiencing any of the below signs with your load cell measuring system? It could indicate that your load cell might be broken. Use our guide below to tell if your load cell is broken.
Signs that your load cell may be broken. Inconsistent display readings. The display readings keep fluctuating up and down. The display will not return to zero when the load has been removed. The zero balance has changed dramatically. The display incorrectly reads an overload. The display reads no load when a load is applied. The display readings do not change when load is applied. There are several reasons why your load cell may be showing signs of the above. These could be due to shock overload, lightning or electrical surges, mishandling, moisture or water ingress, corrosion, broken cable connections, short circuit. There are several checks you could do on site to determine if your load cell is faulty before sending your load cell back to the supplier for repair. Only carry out the following on-site checks if it is safe to do so. Do not attempt them in an ATEX hazardous area. Visual check. A visual check of not only the load cell but the overall measuring system will determine the possible location of the fault. Things to look out for are damage to the load cell, corrosion or wear, deformation, cracks, cable connections and cable assembly, cuts or wear from the load cell to the connected measuring devices, obstructions, anything between the load cell and the unit to be measured, mounting surfaces, level or uneven, mechanical supports correctly placed. Note: for multi-load cell applications, you must disconnect all other load cells from the individual load cell you are testing. Zero balance checks. To test a load cell's zero balance, you need to carry out the following. Disconnect individual load cells from multi-load cell systems. Remove all weight from the load cells. Connect load cell to a stable 10V DC supply. Use an outside source. Measure the load cell's output voltage between plus V signal and V signal. Divide this figure by the supply voltage, in this case 10V DC. Check this figure to the zero balance of the calibration certificate provided by your supplier. If the zero balance figure is significantly different to the calibration certificate, this could indicate that the load cell has been subjected to an overload. A moderate overload would result in the permanent deformation of the strain gauges and would need to be sent back to the supplier for repair, while a severe overload will usually physically deform the load cell itself, meaning that it need to be replaced.
Insulation resistance check. Disconnect the load cell from the junction box, indicator or display. Connect all the leads together using a megometer. Measure the insulation resistance between the leads and the load cell board using a megometer. Measure the insulation resistance between the leads and the cable shield.
Lastly, measure the insulation resistance between the load cell housing and the cable shield. Compare this figure to the insulation resistance figure on the calibration certificate or data sheet. If the insulation resistance is significantly different, this could be the result of moisture getting inside the load cell. Input, output and bridge resistance check. For the input and output resistance, disconnect the load cell from the junction box, indicator or display. Using an ohm meter, measure the input resistance between the excitation leads. Using an ohm meter, measure the output resistance between the signal leads. For the bridge resistance, using an ohm meter, measure the resistance from the V signal lead and V excitation lead. Using an ohm meter, measure the resistance from the plus V signal lead and plus V excitation lead. In most cases, the difference between these two figures must be is less than or equal to 1 ohm. Compare these figures to the calibration certificate or datasheet. If the bridge resistance figure is significantly different to the calibration certificate, this would indicate a short circuit within the load cell. This could be due to a shock overload, lightning or electrical surge.